Meet the Hold Your Horses Mark IV, my biggest, most advanced rocket yet, and it's running a 29mm ST's F-15-8 motor and should reach around a 1900 feet apogee before deploying a 23-inch Iris parachute. Hey everyone, welcome back to Engineered Nonsense. This is Season 1, Episode 1 of my new Mega Projects series. This year is all about rockets, flight computers, and everything in between. Now, what makes this rocket more advanced and frankly more expensive compared to, let's say, my Mark II design, which is tiny compared to my Mark IV rocket, is the electronics and the power of the much bigger F-15-8 motor. My little orange Mark II was a pretty tiny rocket that flew 3 times and it ran on an ST C6-5 motor. And this one you see here is actually the second Mark II I printed, because on the first launch, my shoe cord snapped and I lost the entire bottom half of the rocket, but I did get the nose cone back safely. And yes, I did say printed because I've designed them in OpenRocket and made the model in Tinkercad and printed out these rockets on my Elegoo Neptune 3 Pro. I've printed them out in PLA, which is probably not the best material because of the heat generated from the motors, but I will take extra precautions on my big F-Class Mark IV rocket. Now, in terms of diameter, the orange Mark II has an outer diameter of just 30 millimeters, versus my F-Class Mark IV, which has a beefy outer diameter of 45 millimeters, which is more than enough for all the avionics and stuff I have planned for it. This is even larger than my E-Class Mark III rocket, which I already thought was massive because it had a diameter of 35 millimeters and a length of around 21 inches. But the Mark IV blows both of those out of the water and is almost a full 2 feet long and about 23.8 inches long. Now, moving on to the engineering part of this design. The fins and the motor mount are all in one piece, and there's also a 1/4 inch launch lug. And the whole unit can be replaced if it is damaged, so that's good. And in the end of where the motor goes into is a little lip that prevents the motor from getting pushed too far into the rocket. Speaking of which, the motor sticks out around 10 millimeters below the mount. Now, above the fin can is the parachute bay. I plan on using a 23-inch Iris parachute, which should be good enough and should fit pretty comfortably in this massive parachute bay. Now, moving on to the avionics of this rocket. This is what sets this Mark IV apart from all my other rockets. It uses an ESP32 based altimeter that has a BMP280 to measure altitude, and it has a micro SD card module on the back to log that data. I will get into the technical stuff of my FC in episode 2, so remember to like and subscribe to see that video because it's going to be pretty interesting and it should show you how you can make an FC for yourself, for your rockets, or any other projects pretty easily. Now lastly, the nose cone, which is hollow and only weighs like 14 grams, and it will get screwed onto the avionics bay so that it doesn't pop off and my FC can get launched out of the rocket and lost forever. Let's run a quick simulation in OpenRocket to get an idea of how this rocket will behave and fly, and other things like apogee, flight time, and more. So that's my latest and greatest rocket, guys. It took a long time to design this rocket, and especially its flight computer, which you may not consider a full flight computer yet, but I have tons of upgrade plans and add-ons that'll make this thing great. And I will talk about these in episode 2. To see all that, please remember to subscribe and like the video for more engineering projects and mega projects like this. I've got a lot planned for this year and this rocket. If you guys have any project ideas, please let me know in the comments below.